At number 16, we have function f of x equals x squared minus 6x plus 9, and g of x equals f of x plus k. And they're graphed here. We have f of x and g of x. G of x is equal to this plus k. Well, plus k is going in what direction? 1, 2, down 2. Okay, if it's going down 2, it's going to be minus 2. Okay, so k is going to be equal to minus 2, and we can check that by putting in our equation x squared. I put the first one in already, minus 6x, and we're going to do plus 7 because it's 9 minus 2, and we're going to graph them and see how it changes. It's going to be really, it looks like it's hard to see. Let's try to zoom. Let's zoom standard and see what happens. Okay, and we see that the graph g of x moved. This is our, we have a colored calculator so we can see our y is in, our y1, our original f of x is in blue, and our y2 is in red. So again, graph, and you see that it has moved down 2 spots, so that's your answer. Okay, and you could try all of them in there and see which graph matches that it has gone down 2 spots. 0 will show that it didn't move at all, 2 will show it moved up, and minus 3 will show it moved down too far. That's up to you if you want to try them all, okay, if you're really not sure what to do. But it moved 2 spots, so it really can't be 3 or 0, right? So if you had to guess, if it's moving down, you should guess negative, right? Okay, compared to the graph x squared, compared to the graph of f of x equals x squared, the graph of g of x equals x minus 2 squared plus 3 is translating, is the result of translating f of x. So our parent function here is x squared. X squared, okay? And that makes this graph, right? And our vertex is at 0, 0. So our g of x is saying that it is, I'm just going to copy it, x minus 2 squared, right, plus 3. Now, I know from our work, right, that when it's in the parentheses, it means it moved the function, right, left or right. And in this case, if it's minus, it's going right. Okay, so I know it's moving 2 units right. And I see this plus when it's outside the parentheses means up and down, and it's going 3 units up. Okay, so 2 units right, 3 units up, that is number 3. Now I can check that by graphing what happened. Okay, this moved where? 1, 2, 3 units. Actually, no, sorry. 1, 2, 2 units to the right, and 1, 2, 3 units up. Okay, so it is correct. If you're not sure what to do when you see this, if you put it in your calculator, it'll do it for you. And you just have to count the units in the direction. Okay, number 18, compared to the graph f of x. Oh, it's the same question. Oh, you guys got lucky. All right, we know that's 3. Okay, if the original function f of x equals 2x squared minus 1 is shifted to the left 3 units to make the function g of x, which expression, right, would represent g of x? Okay, so this is hooked on, right? Our parent function is that square. Remember when we talked about our different parent functions, right? This is our quadratic function here. That 2 is outside of it, and this minus 1 is outside of it. So to the left 3 units means that it's addition, because when we're moving left or right, we're using the opposite side. 3 units. That is in the parentheses, right? Because it's part of the square now when it's moving, right? That's going to be 2. And if I want to check it, right, we have 2x squared minus 1. I'm just going to clear that. Oops, squared, delete, delete, minus 1. Look at that graph. That's where it is right here, right? The original graph got more vertical, squeezed, I mean, got more narrow, not more vertical, sorry. Got more narrow. It squeezed a little bit because of that 2, and it went down 1, right? Now, you can graph each one and see which one works. If you started with the first, right, example, you would end up with um, x minus 3 squared, right, minus 1. Now I'm going to graph that. You would end up with this moving to the right. So you know it cannot be that one, right? Because you're moving to the left. You can try all of these, right? But once you get to the second one and you made that a plus sign, okay, and you graphed it, you would see that that one is the one that moves 3 units to the right, okay? I mean 3 units to the left. I'm so sorry, 3 units to the left. So that's your answer. Okay, Caitlin's graph of a function f of x equals ax squared, where a is a positive integer. If Caitlin multiplies a by -2 when compared to f of x, the new graph will become what? So, okay, our graph, let's just say x squared, right, for the time being, because this is our parent graph, right, this quadratic, right? And it wants to know what'll happen if you make a -2, right? It kind of makes this easy for you, this one, right? Squared. Some of you might know automatically what happens, right? I know that if it's not a fraction, right, the graph is going to get narrower. The fraction makes the graph wider. So that's going to be out. And I know if it's a negative sign, right, the parabola is going to be like this. So it's going to be downward. Okay. Now, again, you might want to try it. Original graph, right, is the blue one. The next graph is the red one. So what happened to the graph? Well, it looks like it got, you can see it got narrower. It is skinnier. And you can see that it flipped and it's going downward. Okay. Number 21. The graph of function p of x is represented on the same set of axes. Sketch p of x plus 2. So what does plus 2 mean? It means that it moved 2 units to the left. And I'm just going to take, these are my special points, right? My vertex and my zeros. Okay, so if you see that I moved my vertex 2 spots, I'm going to move this 0 2 spots. I'm going to move this 0 2 spots to the left, right? I didn't do that much calculations. I just took my main points in my parabola and I moved them over 2 spots left. And I'll actually change the color so you could see that better. All right, I moved it 2 spots left, 2 spots left, and 2 spots left. Now, I see another couple of points where I can measure things easily. So I'm going to just put 2 spots left here, right? It crosses here, 2 spots left here. Okay, now, oh, I really can't draw this using this, but I'm going to try. I can't draw it, I can't draw it. It's so hard to draw without an actual pencil on the mouse. I am not an artist. Oof, made it all go off. Okay. I'm going to try my best, but I am not an artist, especially not without a pencil. I'm going to put it in green. Okay, and I'm just going to put my arrows. Yes, they should be where the points are, but it is really hard for me to draw without a pencil, and you would still get credit as well if you did it like that. Okay, some of your drawings actually really look a lot like this, but try your best to get it to where it's exactly like it's supposed to be. It's just very hard for me to do this on a mouse. Some people can draw better than me, so Okay, that's where my vertex should be. Now it's going to ask, I think about, okay, let's see. No, it doesn't ask about the vertex. Okay, so that's it. That's all you had to do for that question. Okay, so now we have another question, another long answer question. A population of rabbits in the lab P of X. Um, it can be modeled by the function P of X equals 20 times 1.014 to the X, where X represents the number of days since the population was first counted. Explain what the 20 is, what the 1.014 represents, in the context of the problem. And I'm actually going to um, do this without pencil. So your 20 is your initial amount or your principal, right? Your 20 is your initial amount that you started with, or the amount you started with. I'm going to change it to that, but initial is good. The amount of rabbits the amount of rabbits that were in the original population. Okay, and the 1.014 represents the rate that the function or the population is increasing. It is increasing at a rate of, and I want to see how much of a percent that is. So 1.4, right, percent, because I moved that decimal place 2 spots, 1, 2, and it's 1.4%. Okay, I answered the question. The number of rabbits that were in the original population is 20. Okay, and what is this about? This is the rate that's increasing. Okay, represents 1. I'm going to actually change this. Represents 1 plus the rate the population plus the rate that the population is increasing. Okay, it really should say that 1 plus the rate that, or in which the population is increasing. Either way, it is increasing at a rate of 1.4%. Determine to the nearest tenth the average rate of change from day 50 to day 100. So I'm going to pop this in to the calculator, and it's going to be this at x50, right? But first I'm just going to put in, and you should write it. The only reason I wasn't writing it was because it's annoying for me to write on here, but you should write it. And we'll look at the rubric in a second. All right, so 20 parentheses 1.014 to the 50th day. Okay. This is when x equals 50. So P of 50. This is so sloppy. I'm so sorry. This is the best I could do. Then we have P of 100. Remember, this is a 2. 20 times 1.014 to the 100th. That's what we're going to do first. Okay, I'm going to put the original equation in, or the original function, I should say. In that we had 20, 1.014, right, to the x. And I'm actually just going to go to the table and find out when x is 50, what y is. So y is 40.08. Okay. Then we have x is 100. And that is 80. .32. Now, average rate of change, that means something, right? That's our slope. So our slope is y2 minus y1 over x2 minus x1. Remember, it is the change in y over the change in x. Sorry. Right? Or rise over run is why it's y over x, right? So we're going to have, I want to see if I could do this neater. I'm so sorry that I had to use this pencil thing. It's not a real pencil, it's just I'm drawing on the mouse. Okay, I'm going to move this over here. Move down a little bit. Okay. Insert the equation here. It's easier for me to write it as an equation. And so we have 80.32 minus 40.08, and that is going to be, I've done it this way. Do it this way. Right, this is on top. And we have 100 minus 50. Okay, so I'm just going to put that in my calculator. And okay, and it gives me point 0.8048. Okay, so the answer it gives me is 0.0, nope, 8048, right? And it wants me to round to the nearest tenth, so it's going to be, it's going to go to 0.80, okay? So your average rate of change is your slope. And I just use the slope formula. So I hope this review was helpful. Good luck, and